Good afternoon, everybody. Give a couple more seconds for everybody to make their way into the room, and we will get started. Awesome. Well, for the sake of time, we're going to go ahead and get started, everybody. So, good afternoon. Happy Thursday afternoon. I'm John Owen, and I'm here with Kish Galapati. This is the state of SIM. So, I'm going to hand it over to you, Kish. Kish is the senior sales engineer with Cardinal Ops. Here to tell us a little bit about Cardinal Ops.
Thanks, John. So I'm gonna actually keep this pretty interactive and do a demonstration for you guys, but just to set the stage for what I'm going to show you in terms of the Cardinal Ops platform, did want to kind of do some very high-level overview of kind of what we see in terms of state of the SIM. So every year for the last 4 years, we do sort of a survey of all of our customers and some of our other partners, and we collect data from different SIMs. Typically, these are very diverse set of SIM solutions ranging from QRadar, Splunk, Sumo Logic, etc., across multiple different types of companies, predominantly sort of Fortune 500 companies. We look at over 10,000 detections across more than 1 million different log sources. And we kind of publish a report around kind of the trends in the SIM world that we see more from a detection posture management point of view. So just some very high level sort of key takeaways from our latest report is that most enterprise SIMs only have detections for around 19 to 20% of all the 200 plus techniques that are available in MITRE ATT&CK, right? So a fairly low number in terms of the coverage of the MITRE ATT&CK space. And then, but you would think that this is a problem related to lack of data or lack of log sources coming into SIMs. But in fact, we see that most enterprise SIMs actually have sort of data, log sources connected to them, or ingesting into them that can cover up to 87% of MITRE ATT&CK techniques. So clearly the issue isn't around a lack of data, it's more around a lack of detections that are focused on using that data for the specific techniques that those organizations need to cover. And then out of the detections that are available, we find that roughly 18% of them are broken in some way. They've got some sort of issue with them that doesn't allow them to actually fire and work correctly. And then many organizations today are moving into multiple SIM types of environments. So we've seen that number growing to 43% this year for a variety of different reasons. The cloud, moving to the cloud and using cloud native SIMs as well as on-prem SIMs, regulatory requirements from different countries for keeping data in those local regions, et cetera, as well as M&A activity by these enterprises are making that multi-SIM environment number go up. So what I'll do next is I'll jump into a quick demo, and I'll show you kind of how Cardinal Ops allows organizations to increase coverage as well as continually monitor the health of their detections, so we can increase the health of detections that are in the SIM. So let me just switch over to my demo. So essentially, what you can see here on the screen is a color-coded MITRE ATT&CK heat map. And what we do at Cardinal Ops is that we're a SaaS service, and we can connect into the customer's SIMs, whether they're on-premise or in the cloud. Essentially, we're an API integration, right? So we'll connect in, and then we'll extract all of the detections and related metadata of those detections from those SIMs. We don't pull the event data, just the actual detections themselves. And we then use machine learning to decompose those detections and map them to the MITRE framework, right? So we map all the detections to all the different techniques in MITRE. And at the same time, we also do health checks and validations on those detections. So we check them for a variety of different things, ranging from syntax issues, parsing issues, all the other prerequisites that the detection needs to run, like its index, its lookups, data models, all those things, are they present and valid? So we look at a number of different prerequisites that the detection needs. And then if any of these detections fail our validations, then we mark those as unhealthy detections. So you can look at each technique by technique. You can see which product these detections came from. So you can see up here, I've got a Splunk, a CrowdStrike, a Sentinel, Falcon. So we can look at detections across multiple different detection sources within the enterprise, validate them, show you where those detections live. Are they healthy or unhealthy? And basically give you a really good idea around what's the true coverage that you have from a MITRE point of view, and what's the health of the detections that you do have there. So once we do that, the next step is really giving you recommendations around how to improve that. So there's two aspects to that. So the first is, if we talk about health, those validations that I talked about that are doing and ensuring that these detections are healthy, we will then, when we find unhealthy detections, we'll open up these issues that will tell you what the problem is, right? Whether that's missing logs or missing data events, or it could be even scheduling issues in the SIEM, or it could be something even as insidious as you're using the wrong pattern in the detection, right? So this is no longer matching in the payload because the vendor has changed something in terms of how they do the logging. So these are very difficult to find because these don't create false positives. Instead, they just fail silently. So that's why we do sort of continuous validation to ensure that all detections are available, that they're all valid. And then we'll give you essentially the correction, the recommended fix, and we can fix these back via the API. So this resolve functionality will go back in via the API and fix these affected rules here so that they have the correct pattern in them and that they'll become healthy again. And we'll then revalidate and make sure that the health goes up based on the changes that have been made. The second aspect that we do is we're trying to increase coverage, right? Remember, we talked about problem of low coverage across MITRE. So here what we're doing is we're giving new detections that are based on where we find detection gaps, but driven by the priority of the customer. So the customer can specify, I want detections across these log sources, these TTPs, or specific to these threat actors that I know are targeting me. So then we will build detections that are customized to the customer's environment, use all of the customizations that they've done in terms of, data models, or they've got custom indexes, custom field names. Because we have API access, we can see all of that. So all detections that we build are essentially bespoke to that specific customer, that specific SIEM. And then we will provide the detection logic here. The customer's teams then can test this detection and deploy it back again via the API. Now, many customers have their own CI/CD pipelines to deploy detections or detection as code. We can integrate into those via our own API to pull these detections into their pipelines and deploy them into production. And then finally, just quickly touching on a new capability that we introduced, which we're very excited about. And we've kind of partnered with CrowdStrike on this as well. And this is essentially a threat intelligence operationalization capability. And what it allows you to do is to upload any sort of threat report, or via a PDF or a link, or we can integrate again via API to your threat feed. And we will then pull that in, extract the TTP level information from there, and we'll build a threat card and show you the relevance of this threat to you, any mitigations that you have, APTs that are using it. But also, more importantly, we will then build these detections for this specific threat, right? So rather than your analysts going through this and then trying to identify if it's relevant and your detection engineering teams then have to build it, we can generate these within 24 to 48 hours. So you can very quickly then deploy these detections into production and mitigate these threats. So that's basically all I've got. So looking forward to having more conversations with all of you regarding Cardinal Ops. Thank you. Thanks, John.
Thanks, Kish. Really appreciate it. All righty. All right, so this afternoon's session is called State of SIEM 2024, the rise of multi-SIEM, advanced data pipelining, and AI. This will be a slight flood of information, so definitely feel free to look at the recording afterwards, just because it will be a lot of content. So a little bit about this talk and what to expect. So obviously we're going to examine the market and industry of security information and event management software, going from essentially the prior approach to what enterprises are adapting to today, market changes, technological innovations, what the impact is that for your security operations. And then hopefully go over some insights and some recommendations on how you can maybe best approach and attack some of these problems and technologies. Quick little agenda. We're going to go over a little introduction and a market overview, kind of introduce what a SIEM is for those that may not be familiar, or to really reframe how we approach it. We're going to go over what the evolution and how SIEM has changed over the past couple of years, what advanced technologies are being adapted into platforms, what a implementation strategy would look like for next-gen SIEM, including solutions to some common challenges, what the future may hold, and then kind of wrap things up with some high-level bullet points. There should be some time for Q&A, but please feel free to use the platform chat, and I'll try to address those as quickly as possible. So intros on myself, I'm John Owen. I lead our security analytics practice here at Fulcrum. And my weekend job is essentially being executive director of NextGen Cyber Ed. It's a K-12 cybersecurity education nonprofit focused on enabling teachers and students, essentially focus in on the large career and skills gap that some of us are experiencing in the industry. I have, many years in many different SIEM technologies, data operations and security operations, automation, coding, kind of all the like. So just jumping into things, what is a SIEM or what is a traditional SIEM? So effectively, this is a data aggregation and data analysis tool that is meant to provide contextual analysis for alerts, dashboards, some key functionality. Obviously, you're going to collect and aggregate logs into typically a centralized platform or a centralized location. You will search across or analyze that data for things that are interesting, potentially malicious, or what is known bad. And then you will either spit out alerts, reports, or some sort of inference based on that data for either security operations, sometimes general IT operations based off of those events. But basically, it enables you to ask and answer questions. So some of you may have known, at least from news articles or everything like that, there's been some pretty major changes recently in the SIEM space. So in March 2024, Cisco completed the acquisition of Splunk. This was 1 month before a verdict from a lawsuit between Splunk and Cribble was actually completed. So kind of sum it up, the jury in the U.S. District Court for the Northern District of California, they did find that Cribble infringed on Splunk's copyright, and they violated the Splunk General Terms contract, which they were beholden to. But the findings were essentially the jury awarded Splunk $1 in damages. They were seeking about $155 million, so they did not get that. But what this ruling really does reinforce is that using another product to ensure interoperability is a legitimate application of fair use. It also reaffirms that reverse engineering is fair use under copyright law. So very, very interesting kind of precedent that is being set here, or has been set here, in terms of how data and data analysis tool sets are effectively meant to work together. Shortly after that, we've seen Exabeam and Logarithm merge together. It looks like the Exabeam will effectively be the leader primary platform that comes out of that merger. essentially blending logarithm into it. And then, as we all know, Palo Alto did acquire IBM's QRadar, the cloud SaaS service, as part of their portfolio as well. How this kind of looks in, I guess, depends on how you think of it, broader, more general sense, or even more specific, is where does that look for changing market leaders? So obviously Splunk is now Cisco, IBM SaaS is now Palo Alto. Even looking back into 2022, Vista took over Securonics. A month and a year after that, Francisco Partners took over Sumo Logic, and then Thoma Bravo had that manage the acquisition and merger between Exabeam and Logarithm. So that top right quadrant has been impacted over the past like 2 to 3 years very drastically. On the right side, only between a couple months in 2024, massive amount of acquisition dollars, investment spent between many, many different companies. We kind of talked about Cisco and Splunk and Palo Alto and Exabeam, but also Anvilogic, DropZone, Profit, StrikeReady, and Symbian all had substantial investments for their products as well. So still very much a growing market when it relates to SIEM. So what's kind of leading these changes? So as we all know, increasing sophistication of cyber threats. So as we progress, cyber criminals also progress as well. This has also led to an explosion of data sources and volumes, very much led by general adoption of different AI and LLMs. We have increasing regulatory requirements globally. And then also between the cloud, on-premise, hybrid, private cloud approaches, and I guess data sprawl that we're seeing is increasing and diversifying our attack surface. So there's very much more things and more diverse things to actually protect within networks. Some features and functionality that have all been kind of crammed together from a release perspective is focused on AI and at least implementing AI into different platforms. So we saw this across Microsoft, Google, and Splunk, only a couple months apart. So, and actually Microsoft and Google within the same month, adapting AI based either natural language processing or we see Copilot or AI assistance utilities into their platforms to give analysts or detection engineers or platform administrators an additional edge to be able to do their jobs better, faster with some of these tool sets. So what this led to is essentially a reanalyzation of how to best effectively use data analysis platforms, and all the connected entities in these growing, blossoming enterprises. No longer is a single SIEM approach really the best thing for these global enterprises. Kish kind of hinted at it earlier, I guess putting it out directly, that there's a large number of corporations that use multiple SIEMs right now to varying degrees of effectiveness, right? So the limitations of having just a single SIEM is obviously there's scalability challenges, not only with data management and data analysis and interacting with distributed teams, but just being able to support the diverse number of tools and platforms and environments that are meant to be managed. This presents difficulties in actually handling diverse data, diverse formats as well. There's limited correlation across different security domains, so especially across cross-platform analysis that requires individual integration, sometimes even custom integration. A lot of the, I guess, financials behind these products don't really lead them to want to integrate with their competitors. This also presents the risk of potentially missed threats due to siloed analysis by having, your cloud team or your networking team or your DevOps team all working out of different tool sets and not necessarily using the same data. This is made more difficult by trying to do all of that and keep up with the complex and changing threat landscape that we face today. So companies must continue to adapt to the landscape so that they can actually keep up. And we've seen this, time and time again with more and more 0 days, insider threat becoming a bigger issue, supply chain attacks actually impacting our day-to-day lives. So I'm hitting a little bit on this, but data diversity is one of the biggest issues and solutions to an approach of secured operations in general. So data diversity across on-premise, cloud, hybrid environments, and how do you collect the data is a real issue and a struggle for most companies. This increases complexity in actually collecting the data and managing the sprawl that happens as different business units may use different technologies within the same I guess vertical stack for either endpoint or network utilities or something like that. So what is a multi-SIEM and what does a multi-SIEM approach look like? So a multi-SIEM architecture is essentially integrating multiple SIEM systems. The goal here is to leverage the strengths that those individual SIEMs provide, and essentially it's a stronger together mentality. The goal there being unified security intelligence so that you're able to do detections or analysis of data that is platform or product specific, and then bring all that together to correlate it to get a complete vision of your entire enterprise. This can be benefited from by using like best of breed technologies, either leaning on people with domain expertise, and also using data management capabilities to actually tie everything together. What are some benefits of SIEMs, or what we will call either multi-SIEM, SIEM of SIEMs, however you want to approach it? So it will give you that increased visibility across all of your systems by being able to integrate them and tying them together. Your threat detection will increase by being able to actually do that cross-SIEM correlation, federated searching, and analysis. You also get the flexibility to be able to use individual best-of-breed technologies, whether that's specific to your cloud security provider or endpoint provider, that are best fit for those needs. This also provides a degree of scalability or increased degree of scalability by being able to essentially grow independently, but have a singular management stack to actually fall back onto. By doing this, and actually combining all of those individual approaches, you do get efficient security operations by being able to provide a longer timeline of contextual information to analysts at the time of triage so that they're no longer siloed or trying to figure out what data lives where or where they go for a particular piece of data in order to make the decisions that they need to make in a short amount of time. So this may lead to like, where is a multi-SIEM approach a best fit? It may not be a best fit for small to medium businesses, but when you look at a global footprint or enterprises that do have a multi-cloud approach or even a vast hybrid approach, it's very beneficial for those because you do have a multi-technology stack to look at there. Managed security service providers have probably been doing this for longer than anybody because they've kind of been forced to from having a diverse set of customers or the ones that do manage a diverse set of customers. Or if you're a company that is global and you have differentiations in your data sovereignty or data protection requirements. Also, if you're undergoing or have undergone M&A activities, and you may have subsidiaries that use different technologies and have not fully either integrated or replaced those yet, you will be left with multiple technologies, or at minimum, you'll have to do that during the M&A procedures and maintaining a multi-stack of products. So what are some key components of a multi-SIEM architecture? What are things to look out for when you're trying to piece together the parts of this puzzle? There's three primary ones. Obviously, you need probably the most important, at least for me, is data ingestion. I hint a little bit on the normalization part. That's certainly a key component of this, but just having that data management schema and I guess solutioned out is, if you don't have that, you kind of can't do anything else. So you need to collect data from the multiple SIEMs or data lakes, data warehouses, wherever your data may lie, or the ability to collect that data, have a degree of standardization, figure out where your real-time versus batch, push versus pull data sources live, and obviously maintain the health and completeness of the data sets. Probably one of the hardest things to look at or at least solve is, how do you get cross-SIEM correlation? Again, these companies are competing in the market, and so their willingness to work together on a technological front, as we've seen with some recent litigation, is kind of questionable at times. So usually customers are led to do this themselves. but being able to actually query and get insights from multiple different sources does lead to that better analyst experience, decreases all of your MTTs for your security operations, and inherently lowers risk. Having a centralized place for dashboard and reporting lets you get a complete health reporting compliance view across everything, and allows you to compare different parts of your security stack to make sure that, again, it's all working together as a holistic system. It's two different slides here I have for these multi-SIEM reference architecture. I'm going to go over them a little bit. Again, reach out after the talk if you kind of want these in more detail. Happy to go over them because they're fairly expansive. So first one here I'm going to go over is a general diagram of a multi-SIEM. So at the top, we have the central analysis platform. Let me see if I can think I'm showing that correctly. Yeah, central analysis platform. So essentially, this will be either a centralized data analysis or presentation software or tool, or could be a quote unquote primary SIEM in the multi-SIEM strategy. Some key components you want to solve or features that you want this to do are actually correlate the data, handle alert management, probably have a machine learning or UBA component, actually solve for incident response and your reporting analytics stack. This could be a single product or many different ones tied together and integrated, which I'll show you here in a second. This also integrates with threat intelligence, not only from, I guess, a direct threat intel perspective where you're actually using it to identify things like IOCs, and also integrates with your SOAR platform so that any, I guess, automated or response actions that analysts may have, that's the interaction layer there. That middle layer there is your data sources. So things like your network devices, servers, applications, suites, network security appliances. That's where everything, I guess, lives from an environment perspective, can be interjected from the source. So if you need to uh, uh, section off a part of the network for remediation or isolate hosts or something like that, that's where that automation takes place. Towards the bottom, we see our data collection and ingestion. So essentially, this is unifying what data collection, data management looks like, how you're going to transform and normalize the data, enrich it with something like threat intelligence, do some sort of aggregation on data sources that may have, high volume, low value, but the value you get out of it is fairly specific or is based on thresholding. And then again, finally finalizing it with normalizing data for these SIEM platforms themselves, where the data will get sent to. The SIEM platforms may have internal, I guess we can call it onboard or provided storage, or you can leverage a data tiering strategy either within the SIEM or holistically for a data lake, data warehouse, or whatever data storage platforms you can come to so that you have readily accessible data, maybe slower data, but still accessible, and then frozen, which may be something that is more compliance or audit related that you look at infrequently but still need available at the time that you need it. So I've also, to kind of go over what uh, vendors may actually solve some of these solutions. This is by no means an exhaustive list. This is about as much as I could fit on some slides without giving whoever sees them an immediate headache. But at the top, we see, a lot of the data centric and data analysis vendors, even moving over into the reporting and BI space, solutions for incident response. What you can see here from a blend perspective is there's some that pop up in multiple different areas. And so what we've seen is enterprises essentially focus in on what combination best benefits them for individual portions, whether you have a more focus on support from your endpoint stack that can actually provide additional capabilities from that sort of platform, or to bleed out into the general ITBI space and take advantages from some of those tools that may already be in-house, and then just kind of lump everything together for that holistic initiative. I'll move down here and show you a little bit more from the data collection, data source perspective as well. Some of the top right Gartner SIEM platforms, and then what we may see for some examples for hot, cold, and frozen data. Talk a little bit more specifically. This is about SIEM, but you don't really have a SIEM without data. So having a very solid foundation of data and data health and data management is a real key component in solving this problem overall. Data pipelines evolved, drastically over the past couple of years. We've seen tons of companies essentially burst up like I guess, Gen 2 SIEM did maybe about 4 years ago in terms of adaptations and evolution. So this can essentially be summed up with, mo data, mo problems, right? So diverse data, expansive data, different data sources, long retention times for data. It's growing in every axis. So obviously collecting the data is one problem. Storing the data is another problem. Transmitting the data is another one, and then actually acquiring the data, or I guess requesting and querying that data is certainly another one, and then presenting it on top of that. So there's many different challenges along the way between the data generation and the data use that really need to be accounted for because each present risk to the business, either from an operations perspective, revenue, or security. I guess the hint here is when you look at data pipelining tools, you may see data pipelining. A lot of, the new thing is observability. So you'll see Ollie O11Y as an observability platform. They used to be called ETL tools, extract, transform, and load. But at the end of the day, what the goal is they're able to either collect data, transform the data, aggregate the data, do something with the data, potentially even route the data. But they usually sit as a middleman between your data source and your data destination or analytics utility. What's a good support for how to actually maintain these systems over time? So it's as a effectively, do you have the data you need, where you need it, and when you need it? You really have to solve those primary three concepts in order to make this actually useful to the people that need to use it. So you have to have efficient data management in a complex world. That can also provide opportunities for cost optimization, right? You have deduplication essentially of data if you don't have agent sprawl on your endpoints. So actually, you get a multi-factor of benefits from unifying the stack across the board. Not only does your overhead go down, but your risk goes down because you can get a better handle on what you're collecting and ensure that what you're collecting actually meets your needs and solves the issues at hand. Another factor driving adoption is, wanting flexibility. There's been, this growing need to, essentially take down vendor lock-in because, support for the X or Y technology may not be there. And it's only on some other product, but they have something that works. And so what does that blend really look like to be able to control where data goes and when it is going to be used? Here are some examples of pipelining tools, just in case you wanted to see what the vendor space looks like here. There's not a ton from a Gartner perspective yet. I assume there will be here shortly as this really becomes fleshed out. Right now, it's just kind of wild west of capability and functionality between legacy ETL and more advanced, more mature pipelining utilities. Essentially the difference between what you may see as like something like a NiFi and something like a Cribble. So Cribble has many products in the data pipelining space. Splunk has done a couple different iterations of this. Observable AI is a fairly recent one. Apache's got their NiFi, which has been around for nearly forever. Chronosphere just had an acquisition about, I don't know, a year or two ago in this space. And then Pentaho also has one they call it codeless data orchestration. Again, it's just data pipelining. So key features that you want to look for when, I guess, investigating or doing proof of concepts or analysis of data pipelining tools. So this would be things like obviously being able to collect the data from your cloud on-premise or hybrid platforms, being able to transmit the data in real time, or at least in whatever time that you would need it. Some things are batch, some things are daily dumps. That's again more complex management for data itself. You want to ensure that you can do intelligent data routing and filtering. This is the right time, right place thing. Do I have to send all my data to maybe my high cost because it's a limiting functionality, or can I actually have the flexibility to send data to multiple tiers of storage or analytics utilities and use the best things where I need to? Are you able to actually enrich that data, add the threat intel, your business unit information, public and private IPs, interrogate things like virus totals so that you don't have to do that upon analysis, so that you can actually use that as influence on maybe what you do with the data, where you send it, how you treat it, or even alert in line prior to actually ingesting the data and maybe taking a license, performance, or compute hit on your analytics platform. Data pipelining also might provide you compression optimization. So you can actually, archive things or aggregate things, or use different compression technologies to actually, limit either egress from cloud service providers or on premise, to keep those not only the costs down, but storage amounts down as well. You may need advanced parsing for very complex data sources. This is where me and my team find spending a lot of our time is actually interpreting event stacks, events, logs, traces, all that fun stuff, and figuring out how to not only digest ourselves but then present it to a technology. A lot of things that we're seeing now is obviously integrating machine learning and AI for essentially anomaly detection at the edge. Obviously, if you don't have to send the data into a platform, then crunch the numbers, and you're able to essentially do that hot on the wire, not only going to be able to respond faster, but you're also going to save money and other things in the back end because you don't have to get it into the larger platform and then churn through it. Additional benefits from the data pipelining toolset itself. It's just essentially just unifying normalization standardization. It kind of just sits across the board. These solve many different problems in security, compliance, reporting, and alerting. Adding that context or faster threat detection or response times. You can better adapt to new data sources and may not be reliant on vendor support to actually come and do that development for you. A lot of things are moving API centric, and having API support can be highly beneficial for actually getting data into platforms. So how do you approach AI and ML and while supporting data diversity? Some of the challenges from this come with maintaining data quality. Obviously, the AI and ML is very much a garbage in, garbage out scenario. How do you select your models and train those models? Of course, if you have good data. What does the adaptability look like for those models across different platforms? How do you actually scale the models if you have a multi-platform approach? And obviously, you need to also address the skills gap by introducing complex data science techniques into a platform. Some integration strategies for this. Obviously, data integration, aggregation, and centralization is key. Being able to essentially have one neck to choke when it comes to doing some of this analysis. Doing things like federated learning, so you can train models on individual SIEM systems and then take those inferences out of the systems for use elsewhere. API-based integrations will aid in the actual integration between multiple platforms. Having a modular architecture enables you to pin in and pull out systems where they best fit, or if you actually do go through, I guess, a change in software, endpoint, or otherwise, it's easier to actually bridge that gap versus essentially having to reinvent the wheel. Things like SOAR automation and workflows are going to be highly beneficial. Having standards for schema for data, alerts, and AI insights is key to actually being able to reuse things across platforms. Actually approaching this in a phased implementation. So don't bite off more than you can chew. Don't try to boil the ocean, right? Have a very strategic mindset when it comes to implementing and using these systems. And obviously using things like threat intelligence as a collaborative tool across SIEMs so that you can actually reuse that data at the base level and don't have to wait for it to actually bubble up to the top. What benefits can integrating AI with a SIEM bring? So obviously things like improved threat detection accuracy, you're not waiting for an individual to actually get eyes onto an alert to detect at least layer one, good versus bad, if there's known things or known behaviors, or at least identifiably repeatable behaviors. You can also use AI for false positive reduction. And that's part of augmenting that human analyst capability functionality. And obviously, if you're able to take that first couple percent of the effort out of the way, you get some level of cost effectiveness as well as time reduction to be able to use your resources as best as they can be used. So how do you implement this next gen SIM strategy? I'm going to go a little bit over what some best practices that we've seen and recommend, some challenges and also solutions to those. So if you do see those, you have something at hand to actually solve that problem. And what does success look like? So kind of jumping in from a best practices integration standpoint, data is key. Having a clear data strategy out the gate, regardless of what your SIM vendor or portfolio looks like, is going to be key. Being able to handle that management. Um, Also, define some standardized data format or taxonomies so that once you have data in an understandable way, you're able to catalog it for use later. Implementing that centralized log management, I don't mean like, hey, put everything in, an S3 bucket or one vendor or something like that. Have a log management strategy or tiered strategy that is flexible enough to support many different approaches. Combining all that together into a unified alerting and incident response process is actually the usability or value behind going through something like this. And prioritize API first. So if you can take on a little bit of burden as a team from an API integration perspective, it will allow you the flexibility with a little bit of extra work, but you're less reliant on vendor provided things because there will always be gaps there. And so being able to just address the small number of gaps that are presented from a technology stack perspective will allow you to move a little bit faster, be more nimble and flexible when approaching some of these things. And since we're talking a little bit about stuff about practices, I do see a question. Do you see Ceph as the way forward to make SIM communication standardized? I don't see Ceph as that. There is the Open Schema, so Open Cybersecurity Framework, OCSF, that looks to be one of the leaders for security-focused SIMs. From a data perspective, it's mostly centralizing on that. So either that or some sort of JSON format where you can just, that's a good standard to have there. They can be used across many different platforms and digested pretty easily by those technologies. So some challenges and solutions when implementing a multi-SIM strategy. Um, Being able to have multi-SIM probably presents you multiple places to acquire data, leading to data duplication and potentially data inconsistency, especially in cloud or cloud supported or cloud hosted environments. So either you can do data deduplication by minimizing agent sprawl on your endpoints or data collection points, or data duplication via the data pipelining. There's also alert fatigue if you do have multiple systems. Again, you can do things like tiering alerts across platforms using AI to bubble up what actually is the alert you should be looking at. This is after any sort of standard deduplication, but because you get added visibility, could lead to higher volume in alerts. There's also going to be a skills gap by introducing, or I guess enabling, multiple technologies. So what you're going to do is probably want to cross-train teams, even leverage outside sources like managed security providers, if they can provide specialized expertise. Generally, the thing is here is empower your local SMEs. So your cloud team, your network team, your endpoint team, those are probably where your, I guess, tier two SIMs are going to sit. Let them control their own domain from a security, I guess, data and alert perspective. They're going to know more about that than somebody that sits at the higher aggregation level, and they'll be able to know what they need to bubble up. But obviously, having that cross-team collaboration lets them show how those technologies interact at the enterprise level. compliance reporting across things is just going to be a bear regardless of what you go, or I guess where you go with one or many SIEMs. But if you're able to actually put everything into a centralized analysis platform and aggregate that data, you're able to report across everything clearer instead of having to report on individual technologies and maybe have to, manually load CSVs or Excel documents and do number crunching or pivot manually to another BI platform. If you can integrate those from your approach, everything else kind of just flows a lot easier there. And then because you're adding visibility here, there is going to be higher data volume. Take advantage of any licensing that you can with certain platforms, obviously. Do things like edge computing. Use the data as quickly as you can in the pipeline, get rid of things that you may not need. So as data starts to flow up in the tiers from to the SIEMs and then into your primary analysis platform, you really only have what you need. But also remember that you may need to just lump sum store most raw data, or at least what you deem as relevant raw data, into some sort of data storage that you can query because you might have questions tomorrow that you don't know of today. Measuring success comes in at four primary buckets, right? What are your KPIs? What are your operational improvements? Do you have cost implications? And what is the long-term strategic value for these platforms? Things like KPIs are how you're doing your mean time to detect and mean time to respond. That should be quicker, obviously. Increased visibility, increased aggregation, and increased contextual information for your analysts will benefit them in the long term regardless. Operational improvements, again, you're not having to wait on siloed communications to happen. This is all a multi-team working together strategy. Things like cost metrics, TCO is probably the leading reason why companies are actually moving to a multi-SIEM approach from a licensing benefit perspective with particular vendors, as well as a people question of, I already have staff working on these domains, let them have their own tool sets and manage those things so you're not having to have an additional team that's just meant to kind of do that thing. And a long-term value, scalability and flexibility, right? You're able to build bigger because we know things are growing, product and data volumes are growing. And also we are not going to have the same technology stacks in the next couple of years that we have today. So go ahead and build for that eventuality. What does the future of SIEM look like? So, and I guess future data pipeline to start out with, right? So bigger and broader integrations with broader data lake solutions like Snowflake, Datadog, and Dynatrace. We've seen this somewhat already, but this will continue across the board. They'll also adopt AI and ML strategies, not only from a data curation perspective, or I guess administration, but actually interacting with the data in flight. We see things now like edge computing and neural chips being put out at the edge. So you're able to do some of that computation before even ingesting the data. We'll see additional solutions around data sovereignty and privacy, being able to segment data in an easier way while also providing the flexibility to be able to use the silos that creates. And kind of like I mentioned with moving to something like the Open Cybersecurity or Schema Framework, is a great emphasis on open standards like the open telemetry and interoperability between vendors, as they really realize that they cannot be on the hook for solving every eventuality. On the SIEM side, we will see continual advances in natural language processing for log analysis. So this is more like interrogating via common languages like English for one, being able to ask those kind of questions like we've seen with ChatGPT and Claude, actually on data specific to corporations. Explainable AI. So this is, hey, I'm seeing something today. I'm looking at data in a format, and I can see, message, event, log type, those kind of things. But what does this mean? What does it mean with the context of everything else? More focus again here, also on the SIEM layer for edge computing, distributed AI. Again, this is either at the platform or even at the data edge prior to platform ingestion, and broader integration with security tools. And what I mean this is almost this SIMSOAR will become one. This is through acquisition and from features, they may not be a full SOAR utility, but they will provide essentially quick actions to be able to integrate with other things like isolating hosts, running virus scans, resetting passwords, those kind of things as they become more analyst focused. What we're going to see in the market is a couple key things. We've seen Cisco, Microsoft, and Google try to target market dominance through pure scale. This is almost going back to a pure platform play, as we've kind of seen previously. It's got its pros and cons. We're going to see more combination of the security and observability. I'm got my own opinions on what observability really means. But at the end of the day, I'm always one to know that, you need every piece of data. And as our own Josh Tatum puts it, during a security incident, all data is security data. So you really need to know what you have there. I'm putting it here on a slide because I do project that although they're not on the quadrant yet, that CrowdStrike's next-gen SIEM, they have a fairly good piece of technology, though. They will be on the Magic Quadrant on the next round because they do very much compete in that space. And I thought that was worth mentioning since it's not clearly stated previously. So how do you keep all of this evergreen and kind of walking into the final part of this presentation? How do you design that future-ready SOC? Avoid vendor lock-in. And yes, I'm coming from a VAR saying avoid vendor lock-in. We love our vendors, but we also realize that pure security comes with being flexible and supporting things, right? You need to actually know that contracts will end, technologies will change, feature sets will change, mergers and acquisitions will happen. Being able to support multiple vendors within your stack, you do that today, just having a key focus on actually supporting that holistically benefits everybody in the long run, not only from a customer perspective, but on the vendor side, because they know that they have a easier integration way. So should new technologies come around, it is easier to implement and actually enable that security within the enterprise. When you're analyzing your tech stack, balance the benefits of individual platforms with their flexibility. So I lean about, 60, 40, 70, 30 towards flexibility in my mind. Nimbleness beats individual benefits typically, especially when you're addressing risk, because time is of the essence during any sort of, emergency situation or incident. Focus a lot on supporting open and extensible architectures, especially from the data side. Have multiple different ways in a managed strategy to be able to support where you're putting your data, how you're acquiring that data, and how you're collecting the data. And also develop strategies to augment those capabilities and how you're able to migrate between providers or adapt into new providers is keys in a little bit with vendor lock-in, but as you do acquire new technologies or get rid of other ones, it's easier to go through that transition period. It doesn't take you 9, 12, 14 months to actually do that. So kind of in conclusion, summarizing all this kind of stuff up, we have key trends, essentially expanding the adoption that we've seen into traditional AI. We've seen more cloud adoption and cloud-focused solutions. We also see consolidation around the cost of the market in this new phase of, an almost re-platforming approach that the market seems to be doing again, just because of dollars. And for SIEMs, the future is moving away from essentially standardized rule sets and having, thousands and thousands of individual detection rules to how to best present and utilize AI and LLMs to detect and triage and remediate threats at the data detection and analysis triage phases. There's also a key focus on having that strategic approach to doing SIEM selection and implementation, because there's going to probably be multiple SIEMs. And so that benefit flexibility Venn diagram does become very important as you look into adopting individual technologies. So I appreciate you walking through that whole entire talk with me. I know it was a lot of content. Hopefully the video and recording will be beneficial if you need to go into any detail on anything I've gone over. But at this time, I'm going to kind of take the last couple minutes here to answer any questions that may come in. So yeah, feel free to ask. And otherwise, thank you very much for attending FCON and attending the State of STEM talk. Hope you have a good rest of your week. I'll wait a couple minutes just in case anybody has any questions. Nothing. All right. Well, again, thank you. My email and LinkedIn's around if you need me or need to ask any questions relating to SIM technologies. But yeah, thank you, and we'll see you at the next one.